Hello everyone, myself Ayush Jaswal, and this is an explanation video of our data science internal one test paper of question 13 in the guidance of Dr. Shaligram Prajapati sir. Now we will see what is data normalization, scaling data to a specific range to ensure consistency and comparability across different features, transform raw data into common scale, ensures fair compression between features, improve machine learning model performance, and prevents feature with large ranges from dominating. Why normalize data? Because different feature have different scales. Algorithm like k-means are scale sensitive, so faster convergence is gradient descendant and better numerical stability in calculation. Equal contribution from all the features, because in when we have a data, the data is of variety, or varieties we can say of so many ranges. So so to analyze the data and get freedom from the data, we use normalization so that we can get insights from that given data. Although the data can be of in a range of 1 to 2000, if data is mostly in 100 to 200, in the range of 100 to 200 and 600 to 700, between 600 to 700, then finding insights from that data becomes difficult. So normalization can help in this, where it makes the data in an limits, like in this min max normalization. X dash means x means normalization is calculated using x, the value for which normalization is to find, and x min divided by x max minus x min, where it scales data in range of 0 to 1. As I have said, in min max normalization, the data is in between 0 to 1 only, so the finding insights from data becomes easy. Minimum value becomes 0, maximum becomes 1, and preserves relationship between original values, and the values that is between 0 to 1 also describe their original values also, so it doesn't change their real meaning. Sensitive to outliers. Now we have this data set in our next question, but we have taken in there. So we find the min max normalization, where we have given 200 and we have calculated it with first initial value. So 200 minus 200 divided by 1000 means x min is 200 and x max is 1000, and we initial value we have taken x0, x as is initial value only, the value from which we are going. So 200 minus x min means 200 minus 200 is 0 only. When we go for 300 minus 200, it gives 100, and divided by 2000 minus 200, it gives 800, and the answer is 0.125. And similarly for all data sets, it is this. So the z normalized calculation will be x minus mu upon sigma, means variance, mean, and standard deviation, where we can see that sigma is standard deviation, pi, mu is mean, and x is the value that we have given in data, where z score normalization is less sensitive to outliers than min max. Again we have used this data for z score, where we have the data 200 and we have calculated the mu, means variance, as 500, and standard deviation as mean as 500, and standard deviation is 283. We have put the value and got minus 1.06 for 200, and 400 we got minus 0.35, and for 600 we got 0.35, and for 1000 we got 1.77. That's how. Now we go for decimal scaling normalization, where the formula is v dash equals to v by 10 to the power j, J is the smallest integer where max v dash is less than 1. Moves decimal points to normalize values. Preserves relative size of values. It is simple but less commonly used today. For the same data sets we have calculated, for 200 it gives zero point 0.5, zero point 0.2, and for 400 it gives zero point 0.4, and for 600 it gives 0 0.6, and for 1000 it gives 1. So the power will be 3 because at 600 it is less than 1, because at 1000 it gives 1, so we will take at power 3. While the comparisons of all three techniques are, where min-max works in range of 0 to 1, it is best for neural networks, and z-score works in range of minus infinite to plus infinite, it is best in regression. In decimal, scaling is used for simple scaling because it is between minus 1 to 1, where real world applications of this are student performance analysis, like age is given in range of 18 to 25 years and their income is from $0 to $10,000, or we can say $1 lakh. Without normalization, income dominates. After normalization, equal feature importance, better model prediction and accuracy. Key takeaways: normalization ensures fair feature comparison, that I have said earlier. Only because of high variety of data, the data deflects too much, so normalization help to compare fair to for fair feature comparison. Now choose based on data description and algorithm. Thank you everyone. If you have any question and doubt, please feel free to ask in comment. Thank you.